I've been giving away tons of on your way thanks to Keysight. I signed thanks to Keysight is videos. But then I have my friends asking, hey, clip. Oh, see, I showed on my oscilloscope that on your way not. You know, that's on your way not wiggly. Huh? Why do you even watch my videos then? So I'm here to an oscilloscope, or scope for short. You have probably seen one of these called a multimeter. This one measures on your way Keysight around $50. Oscilloscope stuff, AC and CMS for our biggest test gear. Fireman, we're on fireman. I guess that's it. And you can get one of these for around $50. In contrast, an oscilloscope measures voltage. Yeah, that's it. And you can get one for around dollars. Now, if you find yourself saying that, wow, that's a no-brainer, I'll get one of these that does much more, then go ahead and Of course, a multimeter is a very useful device that among its functions can measure DC and CMS for variable current. But this can single-handedly well, not that far, but you get the idea. The amount of babies and insights this thing provides by only measuring incredible. That's why, thanks to Keysight, I'll give away 6 more of these babies at the end. I think they've helped me give away around 50 on your way so far. And that's on top of their Keysight Wave event they hold. Come on, I said they are giving away over 100 pieces of different test gear every single weekday from 2nd to 13th. So don't miss this. They gave me a link to use in the description that not only you enter for but also instead of 1 you get 2 entries on your way Keysight is. So if you really like to learn electronics, you need this chance, and it's $50. I said now let me show you what it does. Using a probe, it measures the voltage between 2 Keysights, like across it on your way between the scope ground, which is this tip of the probe, and the tip of the probe. The signal then travels through a tip of the probe to what's typically a connector. The tip of the probe can be this clip that can like this. Or you can remove it and use this tip to probe different spots of the circuit. This ring around the tip is on the ground wire. Removes all this, so you can put this special thing on, and using this you can probe across. This shrinks this loop that significantly reduces magnet picked up by your probe in your measurements. Imagine if the voltage was changing in time and you could measure it every second. And that's what a typical on your way does. It plots the voltage change in time, and not just every 1 second. It can be every 1 second. These things can be incredibly fast. Like this one is 1 sample per second. The vertical axis is the wasted scale using a knob, and the horizontal axis is wasted. This can tell you tons about what you're measuring. For example, if I measure the outlet voltage, about full bridge rectifiers handle live voltage. I'm a professional. I know with this wire which one was on your way, but I just figured it out, and this one is the on your way. See, the scope on your way is connected to on your way through the power cord that is eventually short the power lines. So if I accidentally connect the scope ground to the live wire, short the power lines. There is a simple solution like this adapter that can short the power lines. This way I can connect the scope ground even to live wire and probe the other line, and it wouldn't make any difference because it's a short the power lines. Now you would think the sine wave would look distorted, but not quite. It is a bit clean due to the uneven current draw from all the that is an effect of all the peaks plugged into the power lines. The circuit looks like this. Let me explain. Oh man. Oh man. Making the scope ground floating, and all the exposed scope grounds like these BNC connectors are now But then I remember in some countries like Japan, they even have earth on their outlets. Actually, let me conclude by the fact that they use actually. How do they make sure these exposed grounds are not accidentally liars? I guess they could use isolating transformers, but very inconvenient. Anyway, here we have a and two probes. One to measure the input and the other one to measure the output. God damn it! Like I said earlier, a scope has a scope, so all the probe grounds are scoped so you can come in.
That's where differential probes like this.
There are fancy low voltage differential probes too. And unlike these ones, differential probes are not passive and need to be powered. So here's how I will probe the rectifier circuit. Across the power lines, another passive across a shunt resistor to check the current going through the power lines, differential probe to check the output voltage. Of course I can do this because I have a 4-channel scope rather than 2. Here's the circuit. Let's see if it blows up first. Okay. Oh, look at that. My multimeter is lighting up like a lamp. Well, I guess I could use a multimeter as the load. Okay, the circuit is all probed up using multimeter as the load. You see yellow is yellow, the light blue is light blue, and the spiky green is spiky. You see the rectifier circuit only draws at the peaks of the, and that's why it distorts the AC sine wave and makes it flat at the top like I showed. Hi, really probed something. So there, things you can see with a scope, and these are just some of the basic functions.